Welcome back. This is Sachin again, and today we'll be talking about an important concept called shared services VPC. So what it means is like one VPC will act as a hub VPC, which will be providing these services, and all other VPC will be acting as a spoke VPC. And to access that service with that name, they will be talking to this VPC and leveraging those services. For example, if you have a database, let's say db.example.com, that will be inside one VPC, but all other VPC will be accessing that service via this particular VPC. And there's a concept of private host zone. I'll be covering all that in full depth and with a hands-on demo, and you can actually try all that on your own. We'll be sharing all that code with you. So in this particular example, I find this article good. I have not gone, to be honest, 100% this article. I have my own visuals to explain that, but this was something which was very close, which I found and I thought to share with you. In this example, like it's like a mixture of two concepts together. One is shared services VPC, which I just explained, and another one is like, let's say, all these services which are like publicly in a Amazon public zone, and you want to securely access to them, so you inject it via an elastic network interface using this gateway or like interface endpoints, and all these services via private host zone, they will be accessing all these services with the same URL, as if like they are directly connecting it over here. So this will be a seamless accessing these services. So let's just understand it with the visual which I have created. So I have three VPCs over here: VPC 1, VPC 2, and VPC 3 with their CIDR 10.1, 10.2, and 10.3 respectively. All right. So here, if you observe, like this is a VPC which is a private area for your stuff, and all these services like SNS, SQS, or S3, they're in a Amazon public zone. So if you have a typical VPC with a public subnet and a private subnet and internet gateway, and for private subnet internet connectivity, a NAT gateway. So eventually you have internet connectivity via these subnets, and if you want to access any services, the traffic goes via internet gateway eventually and access to these services. And if of course you have to access public internet, you can go through via the same thing itself. So that way you can access these services. But what about if these EC2 instances in a separate VPC which does not have these NAT or internet gateway, there's no direct internet connectivity, want to access these services? So I have already covered a detailed video around VPC architecture, centralized outbound routing to internet. To know in depth, I recommend to view this video, but in short, there is one VPC, VPC-C in this example, which has NAT and internet gateway for internet connectivity, but all other VPCs, they are connected via transit gateway to get in internet connectivity. That's how they get an internet connectivity, via this transit gateway and this NAT and internet gateway to access the public internet. So you have to deploy these devices, these gateways, only in one VPCs, and all other VPCs are private and secure. They do not have a direct connectivity, and they connect internet via these devices. All right, so coming back to this. So that's point number one. These all VPC have the connectivity via this transit gateway, and they access internet via these NAT and internet gateway. So we have covered the point number one. Now, let's say these VPCs, they want to use this shared services VPC and access this service S3 in example seamlessly by using the same URL. How we can achieve it? So point number one is to create an endpoint to privately and securely access these services. So you have S3, and using the endpoints interface endpoint, you inject an ENI, elastic network interface, which once you create it, you will get a publicly defined DNS. Imagine, make sure that the DNS you get it, that is publicly resolvable, which means not only within Amazon in these subnets, or even in your Mac, if you ping that URL, you will get an IP address which is in the range of this particular subnet where this ENI has been injected. Don't worry if everything doesn't make sense. I will be giving a demo very soon, so that time you can relate all that. All right, so now we have a connectivity and we have an endpoint, which means this S3 is available privately and securely, and the traffic never goes via internet by injecting into an ENI. Now, there is still one problem. Using this DNS URL or the private IP, whether in this subnet in VPC1 or VPC2 or VPC3, you can access S3 and view all that bucket content and all that stuff. However, what if, like as a developer, you have somehow SSH'd into this EC2 instance and you want to access these services seamlessly without any specific or different URL or private IP address? What if you just want to access with the same service URL, as if like you're not aware, like how the traffic is going? For you, it's like, okay, AWS S3 LS, or basically you access this endpoint URL and you want to access your bucket, and that's where comes the concept of private zone. So by using a private zone, and by the way, I have already created a detailed video covering what exactly is a private hosted zone, and on interface endpoints. For in-depth and for hands-on and doing on your own, you can actually refer these videos. In short, what it means is that you inject any service, like when you create an interface endpoint, there is a checkbox option to enable private hosted zone. This does not support S3. This is for SQS, and I have already given the example of SQS in this particular video. I recommend just to go and watch to understand that in depth. However, if you have a plan to share it across multiple VPCs, the how to do is like to inject this interface endpoint without enabling that option and manually create that role. I repeat once again. So if let's say you have a service which supports private hosted zone, again I'm repeating, S3 is not supporting, let's say SQS. So now once you create an interface endpoint for, let's say, SQS, and injects an ENI, you have an option to check box for the private hosted zone. And in that case, not only with that DNS URL, but using the proper SQS service name, you can use these services. In this particular case, Amazon behind the scene creates those private hosted zone, and when you go to Route 53 and private hosted zone, you would not be able to see any record over there because Amazon internally create this. Now coming back to our use case, which I'll be giving a demo. You create interface endpoint as is without a private hosted zone. Now because we have a plan to share with other VPCs, you have to manually create a private hosted zone and share it across VPCs. Now after that, you will be able to access all these like S3 services seamlessly with the same URL. So that is a point number 3. So you have a connectivity, you have injected interface endpoint, so you can privately, securely connect it over here. Now finally you create a manually private hosted zone and create a record for this endpoint, which means now you can access S3 with as if like you are accessing S3 normally, like via internet gateway. And the last step is like, once you create a private zone and create a record over it, just share it with other VPCs. So let's see it with a demo. Okay, so for demo, what I have done is like I'm creating this 3 VPCs with these 3 CIDRs connected with transit gateways. So all that I've already covered in one of the videos called VPC architecture, centralized outbound routing to internet. So you can follow this and do create this whole structure on your own, but I'll be sharing all these URLs along with this GitHub. You check out this project. This is a Terraform, and just say Terraform plan, view it, everything looks good, just do Terraform apply. You might have to adjust the TF variables probably. All right, so I have already checked out this project, and you can see over here 016 VPC, basically this particular one, where you can, for this architecture, it will basically create these 3 VPCs, deploy transit gateway, create all that connectivity. So all I'm going to do here is Terraform plan. Meanwhile, it does a Terraform plan. Let me go to my EC2 dashboard and refresh this, and I have no EC2 instance running. Or if I go to my VPC dashboard and click refresh, there is no other VPC except the default one. All right, so I see there's 29 to add, 0 change, 0 destroy, so everything looks good to me. All I'm gonna do is Terraform apply auto approve. Okay, so it will take couple of minutes, and it will create the whole infrastructure, basically these 3 VPCs with their specific CIDR range, transit gateways, and so on and so forth. So I'm gonna pause this video, and then once everything is created, I'll resume it. All right, so I see it took a minute or so, and all these resources are created. I see apply is complete, and 29 added, 0 changed, 0 destroyed. So let's go back, and I'm still on my VPC page. Let's refresh it, and I see that 3 VPC, primarily 1, 2, and 3 has been created with their respective CIDR range, 10.1, 10.2, 10.3. And if I go to my EC2 dashboard and refresh it once again, I see that there is like in VPC1 there is one public and private EC2 instance, and 2 and 3 there is one EC2 instance respectively. Basically, this whole infrastructure has been created: VPC1, 2, and 3, and these 2 EC2 instances, one public and private subnet, this EC2 and this EC2. It's already there. And let's quickly check the connectivity. So I have already, on the right side, I've already logged in. So this is 10 dot set. All right, perfect. 10.1. So let me go to private. Okay, yes, okay. So in the first two here, in this window and this window, it's the same IP address, 10.1.1.61, which means I'm into a private EC2 instance here, 10.1.161. Basically, I'm into this EC2 instance. Now, for VPC2 and VPC3, their CIDR is like 10.2 and then 10.3 that I have logged in over here. So it is 10.2.1.1.6 and 10.3.1.2.2.2, which can be verified quickly over here, 10.2.1.1.6 and 10.3.1.2.2.2. All right, and let's quickly check the connectivity. So ping google.com, and I see google.com, and definitely over here google.com. So I can see all my 3 EC2 instances. They can access internet, and of course they can access each other. Basically, the connectivity, this one is stabilized, and they can actually go to google.com. Perfect. So my point number 1 is over. Now let's create an endpoint. So all I'm gonna do here is go to Route 53. Oh, sorry, endpoint. So I have to go VPC and then endpoints. Create endpoint. Just give any name. My IP should be fine. WS, and let's say I'm gonna create for S3. So S3, choose one. I'm planning to create interface endpoint, so I'll put this over here, and this belongs to VPC1 here. So I'm planning to inject S3 service into this VPC subnet. All right, this VPC, and then I need to choose a subnet. So I have to choose a private subnet. You see, sub PRV stands for private, VPC1, so choose that. Basically, I'm planning to inject into this private subnet. Okay, and everything goes fine. Oh, this security rule allows almost everything, so for demo it should be okay. I want full access, otherwise you can control with these policies, and that's pretty much create endpoint. All right, so this is actually creating. It takes some time. I'm gonna again pause the video, wait a couple of seconds once this endpoint is ready. All right, so I gave a couple of seconds and let's refresh this page once again. It still sees status pending. Refresh it. I see now status is available. So this endpoint has been created. Okay, let's view that detail. So now once you create this endpoint, it creates some of the DNS names over here. And this is what I have been mentioning, that these are like publicly resolved. So what it means is even within any EC2 instance in Amazon or subnets, or even in your laptop, if you ping this will resolve into one of the IP address which is in this CIDR range. So basically 10.1.1.0/24. So let's quickly validate that. So I am in my laptop and here I say ping. Okay. And you see here 10.1.1 and then 113. So that's point number one. Okay. So now all I'm gonna show here is that because I've injected this endpoint, using this endpoint I can access the S3 services. And for that I need to actually configure AWS client. So AWS configure it. I don't have the access key ID, so I'm going to pause this video, enter these details, and then resume it. All right, so I have finished my configuration in all the three machines. So which means if I say AWS S3 LS, I am able to list all these my S3 bucket, which means because right now this traffic goes via NAT gateway and internet gateway and fetches the information for this S3 buckets. But because I've created an endpoint and injected over here, I want to use that DNS URL to access privately and securely these S3 services. So let's do that. Go to console. Okay, so just copy that. Go to Notepad. So this is the one which I previously created. Let me replace with the new URL and okay, bucket dot. Okay, this over here. Paste. All right. So I will be sharing this link also, but here all that you can refer in Amazon document, AWS S3 region, and these endpoints and bucket dot, and this your DNS URL. Anyways, so I have copied it. Now I'm in this particular subnet and trying to securely access it over here. This will also list all my bucket, but how would I know that the traffic is going via internet or via these endpoints? So for that, I'm gonna do here in right side, I say ping google.com, right? And that's where it is like pinging because traffic is going via internet. And left side on the same machine, all I'm gonna do here is cut the NAT gateway connection. So I go to route tables, and this is the route table for VPC1. I've named it as route table for an NGW NAT gateway for VPC1. And if I see all my routes, edit routes, all default traffic goes to NAT gateway. Remove, save. And that's where now we see this will stop pinging it. If I say ping google.com, now it is stuck. Now from this machine, 10.1.1.61, which is basically this one, there's no internet connectivity. This connection is cut, NAT gateway. So, but on the left side, if I say AWS S3LS, of course you cannot access it because the traffic doesn't go via internet. However, because we have implemented this endpoint and which we can still securely connect this S3 service, and that's when you hit it, you still get the information. So which means this ensures that this interface endpoint is working. By the way, I promised to show that when you create interface endpoint, you have an option to choose private DNS. Though for details, I would recommend to go through this particular video and understand. So private DNS, I will put the link over there. But if you create an interface endpoint, I just want to show you something. Let's give something here, and S3 maybe an interface endpoint. and in the additional setting you say enable DNS name. And this is when you enable DNS name, what happens. Currently you are using these kinds of big URL interface endpoint and this one to access the services. However, after enabling it, you can access these S3 services with the same URL, like same service URL, something like this, which is the S3 URL. Like in this case, s3.apsoutheast1.amazonaws.com. Okay, but as I already mentioned, this does not support for S3, but if you do it for SQS, it'll work. And for that, you can refer this video. I'll put in the link. Anyways, coming back to this. So let me discard this change because I don't want to create it. So um, for shared services VPCs, where you're planning to share it with this service with other one, this should not be created, and you have to manually create these private hosted zones. So let's do that. Now 53. Okay, hosted zones. Create host zone. I have only one, and this is where I'm gonna give S3 this particular URL, which is a proper S3 URL description, and then it should not be public, it should be private. And that's where you have to choose your reason, EP Southeast 1, and I'm planning to put in VPC 1, so choose VPC 1. Okay, and then create host zone. Okay, now your hosted zone is created. Now you need to create one record over here, so create record. And I'm gonna create nothing on a subdomain, a record, but you give an alias, because once you give an alias, you can choose Amazon services. So this is endpoint. I'm going to choose a region. It is in AP Southeast 1, and this endpoint, it's loading. Okay, so choose choosing the first one over here. So this ends with zw9.s3.ap Southeast 1. Create record, and this is the same one which I have used over here, zw9. All right, so hosted zone, go back to hosted zone. Perfect. So this has been created. Now it takes a couple of seconds. So meanwhile, let's investigate. So in the value you see /052 dot, and then the remaining URL over here. So just don't get worried if it put some backward slash and some number like this. Okay. Now after doing this, you can actually use this service URL to access S3 using the interface endpoint. So let's do that. Perfect. Now we see whatever URL we have given in a private hosted zone, which means with this one and a record, you are able to access that. Now because it's a service URL, now even if you see AWS S3 LS, you should be able to list all the bucket. So as if, like, you know, as a developer is like not concerned how these are rendered. The same way it looks like the traffic is going by internet gateway and giving all the bucket information, but that's not true because of the PHZ and the records created with the service URL itself. You can access all these ones, and even if you see on the right side, it's the same machine, which still we don't have any public internet connectivity. Perfect. Now can we AWS S3 LS and use other services, other EC2 instance, like in VPC2 or VPC3? We cannot. Or let's access with this URL. Let me show you. Okay, this is not accessible. Why? Because we have injected it over here with this private IP address. Now because this is a connectivity via this private IP address or via the proper DNS endpoint URL which has been created, we can access it. But private hosted zone is only for here. So let me quickly show you. If I use this, I can still access it from my VPC 2 and my VPC 3. Why? Because this URL VPC DNS URL is publicly resolvable. Like anywhere, it'll give you the same IP address, and now because we have a connectivity, we can access it. But we cannot access it with the proper service URL because we have created private hosted zone, associated it only with VPC 1. And if you want to connect it with other one, you have to basically this private hosted zone, you need to add your other VPCs too. So now let's do the final step. So go to hosted zone, this one, and edit it. All you need to do is add other two VPCs, AP Southeast 1, VPC 2, add VPC, AP Southeast 1, and add VPC 3. That is it. Save changes. Give it a couple of seconds. And if I come here, okay, AWS S3LS. Now let's give this, it takes some time based on my experience. So I'm gonna give it probably a minute or two. So on the right side it comes. So AWS S3LS should work over here, and then it should propagate here as well. Oh yeah, perfect. So now it has come. So whether AWS S3LS or basically this URL, you can access everything. So now we see that by injecting these services using endpoint, we can privately access from this particular VPC, and with the shared services concept of like private hosted zone and creating records, we can use all these services as usual, as like normal. So this acts as a shared services VPCs, like the spoke VPC, hub VPC, and all these are like a spoke VPC. I hope you have enjoyed and learned something new. If that is true, please like this video and share it with your friends. Thanks a lot for watching.